Hello, I'm Jack Rickard, and this is Electric Vehicle Television, EVTV. This is my compadre and consigliere El Bueno Noto.
And here we are in sitting in the midst of what, the heat wave of the century here in this part of the country?
Actually, Brain, you're from Southern California. This is sort of the normal heat wave that we used to enjoy here all the time.
So this is global warming?
One of my theories about, well, they've gone from global warming to anthropological climate change.
Yes, right. Yeah.
ACC.
ACC.
See, that's mostly a fearful item to people who have good weather.
Yeah, right.
Here in the Midwest, it may not even be a bad thing.
That's right. I think it may be okay. Yeah. We can grow some more grapes.
Yeah, right. I planted some tea, which actually doesn't grow this far north, but armadillos don't show up this far north either. And all of a sudden we have armadillo roadkill all over Missouri. So something's going on.
Well, usually it's the nuclear experiments that cause the either the rodents or the insects to grow giant.
In the 50s, yeah, they had a lot of problems with that after those early tests.
Those ants, out in the desert.
Ants, spiders, mice,
women,
and stuff.
Women grow 50-foot women,
50-foot tall. Yeah, it was. They were hard to see, but a lot of times you could see the shadow of them.
Coming
and see people screaming a lot.
Looking up their skirts, a real treat.
Yeah, right. Oh my God. What's going on in the world?
Well, I guess we've had a little bit of news this week. Just some of the kind of funky news that I found. I guess BMW has committed to delay the launch of their electric vehicles, their small, the 3 Series and their 8 Series sedans. And I guess Audi had already done that, and now BMW has. Volkswagen, we haven't heard anything from, but they just kind of issue press releases.
They're in kind of a press release hysteresis right now. It's Audi has backed off, and they recently captured the world record for an electric Audi A8 e-tron at the Nuremberg.
Oh, at the Nuremberg Ring, yeah, that's right, they did that.
And are implying that will go production while they're announcing that they're not as committed to electric cars as they were.
Right.
BMW has said, did we say electric i3 and that was
fire that person.
We talk about a lot of things here at BMW, and that's not necessarily what we're going to do. That's what we could do.
Yeah, we have the capability.
And so we're seeing a widespread retrenchment of electric car plans among the OEMs who had been announcing all they were going to bring us in 2013 and 2014, that maybe we'll wait and see how the Volt and the Leaf do.
Okay, all right.
And because it's not doing very good.
No.
And so that's kind of where we're at. And I knew this would be a setback. BMW is pretty fast on their feet. They do kind of low volume OEM production.
Right, yeah.
And they're one of the most profitable automobile manufacturers.
Really? No, I didn't know that. No.
Yeah, they're kind of high margin, low volume.
Okay.
And they've also this week announced their discontinuance of their cooperation with General Motors on a fuel cell technology.
Yeah,
but
they're doing something with
announced
Toyota,
an alliance with Toyota.
Right, that was something else.
On their electric cars and fuel cells, and so now these are research alliances. They're not imminent products.
Right. Yeah.
But I believe that BMW could be a player in the electronic space in a way that General Motors and Nissan probably never can be.
Yeah, they're just maybe too big. And BMW's not.
Well, they're too big, and we're just not too mass market.
Right, and we're not there yet. Yeah.
This is not that OEMs can't make electric cars, guys. They can make them better, a lot better than I can. Here's the problem. They keep attacking it from the wrong end, and I've been saying this for 2 years. It has now proven pretty much 100% to be so, exactly the way I called it. And that is that you can't take a $20,000 car, put $20,000 worth of premium components in it, and sell it for $20,000.
No.
And
That would be
so
novel.
then you're going to try to sell a $20,000 intro economy car at $40,000, and who's going to want that? All the people
that
that can
many
afford it don't need an intro economy car.
Right. At this point, in the curve,
Meanwhile,
yeah.
Tesla goes to the other end and takes the top end of European sedan design
Yes.
and says we're going to take this and we're going to make it electric and bring it in at kind of the same price as a BMW
Very
750i and an Audi A8
Yeah, we talked about that last week.
last week, and it's going to be electric.
Right.
Now, what would the difference be? Well, Tesla can sell their cars,
Right.
and Volt and Nissan can't. Now that gets a little garbled because of the price difference. That's
Yeah.
about what Volt and Leaf have sold, is about 25,000 cars
Right.
at $40,000. But they're talking about selling 20,000 at 80,000.
80,000, that's a different story.
And it's just a very different thing. You have to have early adopters fund further development and further speciation of the genre.
That's right, the commingling of the juices.
And so I think BMW could do very well with an i8. And I've actually shown their commercial for their i8 on our show.
Yeah.
And it's a fantastically innovative concept. And they are making the right moves.
Yeah, I think so. Yeah.
They've done that partnership here in the U.S. on a carbon fiber plant.
Oh, really? Okay.
Yeah, this is a different drive. It requires different materials. Everything you know about aluminum in automobiles and why it's not a good thing is no longer so when you make an electric drive.
Right.
Everything you know about carbon fiber and how expensive it is and how you can't put that in a car goes out the window when you start talking electric drive.
yeah.
Now they start to look appealing. And so we're going to go through some changes.
Good. Well, we like chaos.
I do.
Yeah,
But,
yeah. Things
trying,
happen.
Trying to figure out what's going to happen in the future is a big part of being a player in the game.
Absolutely. Yeah. Let's see. A couple of charging stories. You know, it's been funny, all of the build outs of the charging infrastructure in cities and urban environments, places like that. They have done some studies. I guess CNET did something, and there was a residential energy consumption survey done in 2009. They kind of re-looked at some of the numbers. You know, the best place that they're saying for the implementation of electric vehicles actually is in the United States?
Where?
The Midwest.
That's where we're at.
That's where we're at. Single-family homes, garages.
Lots of garages.
I mean, they'll steal your extension cord in the city. You got it plugged in. I mean, you got to come out and hey, my car isn't charged. Oh, there goes another extension cord, and they're what, $40 for a good extension cord?
They take it down and sell it for $10 for the copper that's in it.
That's right. They salvage your extension cord. So, and all the things we talked about, everybody raced out and just madly dashed into the fray. And it is kind of getting better. It's kind of settling out. The OEMs are kind of figuring out what they might want to do.
I don't think they're even close.
Yeah.
Tell me about your story, Blink.
Oh, Blink. Yeah, Blink. Apparently, this was in the Christian Science Monitor, and John Volker, I think, he does some blogging, I think, on the web. He,
Badly, but yeah.
Yeah, he put this together, and they're talking about apparently Blink's Ecotality network, which is really what they've been touting, is this ability to find the charging stations, have 800 numbers, and have these charge stations that are RFID for your cards and everything, are not very good. They have, speaking of telephone numbers, but apparently the 800 number doesn't work very well. I think they've gotten maybe $115 million in Department of Energy money, and can't seem to get it together. The remote controls don't work, they're not very reliable, they're down a lot, they take a long time to fix them, and in fact, apparently they got slammed in a Romney ad, and they're under investigation by the SEC.
Well, they should be.
Yeah, it's crazy.
And so should our government. This is vanity vanities. This is ready, fire, aim, and has been for some
It has
time.
been, yeah.
And they're putting 4 at the Social Security office here in Cape.
Yes, they're going to
that-
put forward Social Security office.
Probably with the Avcon connectors from
Yes,
1997.
paddles.
No, they did at the federal building.
They've got them over there, yeah, still zip tied together.
This doesn't make any sense at all. It comes from a combination of electric car enthusiasts who are in the wrong century.
Right.
If
Yeah.
you have a lead acid based car with a 30-mile range, wherever you stop, you want to be able to plug in.
Yeah, even at a stoplight.
Because within a year, you're getting 11 miles.
miles, that's right.
So the stoplights ought to be wireless
That's right,
charging.
got to be wireless charging at the stoplight.
Lithium batteries arrived in 2008. I have carried this news, and I will continue to carry it. The British are coming. No.
Oh.
The Chinese are coming with lithium batteries. And at that point, you can do 80 to 100 miles. You charge in your garage if you have
If
one.
you have one, if you live in the Midwest, it's easy.
And that's pretty much it. Now, where would public charging make any sense at all?
I guess at a gas station, if you can charge fast.
I hate gas stations. I never want to
But
go
we'll
to a
put
gas
you over
station.
by yourself.
But,
But there's
yeah.
Twinkies at gas stations.
Well, I know. I'm off Twinkies. I don't know if you've heard.
Oh, yeah, I have. I've heard the moaning.
No more Twinkies, and that goes for ho-hos and ding-dongs
the
too.
whole thing, the whole genre is out, huh?
And so until we can get to a fast charging scenario where you can charge your car in 30 minutes to an hour, it doesn't make any sense.
No, it's just too long, yeah.
And we don't even have a standard for that.
No. not for
We
the fast
have
charging.
the Tokyo Electric Power Company introduced the Chademo, which is cha deska, which
Yeah,
means
what-
would you have a cup of tea?
Have a cup of tea.
Because it's supposed to charge in the time that you would use to drink a cup of tea. If you've been to Japan and the train stations and everything, they always have little guys selling tea and soup soba, where you can grab a quick bowl of soup or a quick tea in 15 minutes and be on your way.
Okay.
And so all that
Places
works,
to go, yeah.
except it does not work with the horrendously ugly SAE combi plug
combi
that
plug,
they have
yeah.
now proposed, and neither of which have anything to do with Tesla, who has
That's
their
its
own
own
plug,
thing, yeah, right.
which ostensibly can do up to 100 kilowatts of power.
Man,
And
that's a
so
monster.
we don't have a standard for fast charging. We don't have the power sources for fast charging. It basically is going to take solar and battery banks to do this.
it, yeah.
And so it is a significant investment. I kind of laid out what I think Tesla is going to do on the blog. I don't remember.
We
Did
did
I
it
talk
on the
about
show
it
too.
on
Yeah,
the
that
show?
was like 2 weeks ago, I think, when I talked about it on the show.
Yeah, it's actually quite fascinating. It's going to be done, I don't think by Tesla, I think by Solar City.
Right, which is one of
One
the
of
other
Elon's
other
other
companies.
triumvirate
Right.
of companies. And I see a whole series of Solar City stops in California and maybe throughout the land that are solar powered, battery banks with ho-hos and ding-dongs, where
All
you
the
stop
amenities.
in and fast charge, and perhaps even get into a better place type battery swap thing with the Tesla battery pack that they can apparently change in a minute. The modus operandi there of Solar City is you don't own your solar system on your roof.
Oh, the way their business model right now for Solar City.
Yeah, I mean, you can say you do, but Solar City and the bank does.
Mm-hmm.
It's all a financial hedge fund
To get it
type
up there,
thing that puts it up there, and you don't really pay for it, and it doesn't really cost you anything, and you don't really get any savings on your electricity. The savings on the electricity goes to pay for the solar thing. So why, and I've really been against this with the Shaw Gassy and Better Place thing. I don't know why I roll over on Tesla on it, but there is some advantages. If you're in a plan for batteries, like a cell phone plan, what do you care what the next chemistry is?
No, because they'll have it.
It's
if
not
something available.
your battery isn't going to become obsolete because you're
don't
not
have any.
going to have to upgrade it because you're in the plan and they'll upgrade it when they upgrade it. And so you don't have to worry about your battery going bad because you just take the car down to the place, swap it off on another battery.
Right, and it's their problem.
And,
leave it there and let them
so
deal with it.
it's not even a function of maintenance. It's you just swap batteries all the time whenever you want to, and that would work fine. I think he's dying to tell us about the supercharge.
The
thing.
supercharge.
And the supercharge. That's like I was down in Texas. My brothers lived down there. I learned a couple of phrases, and my favorite is, "Y'all going down to Super Center?"
Is that Walmart?
Yeah, Walmart, Super Center.
That's Texas for Walmart.
Yeah, so we're going to have a supercharger.
Supercharge.
And so I think it's the reviews are coming in on the Tesla.
Oh, okay.
They're driving them and rushing to post on YouTube. Pretty soon you won't be able to see videos other than Tesla.
All just Tesla owner
on
videos.
YouTube, Tesla owners.
The Tesla channel.
It's everybody that's looked at it. Wired, CNN, CNET. They can't find anything to say about the car is the biggest problem.
Really?
Nothing negative.
Nothing negative, yeah.
I have not heard a single negative. I expected to hear something about wind noise or something or rattles or, cheesy interior plastic or, there's always something to complain about.
Yeah.
Can't buy one.
You can't even lose a quarter in the seats?
You can't lose a quarter in the seats. It actually, there's a vacuum system behind the seat that moves it over into a special toll road quarter depository where when you pull up to the booth, it automatically spring ejects a quarter into
shoots
the
it
air,
up. Yeah,
and you grab it and throw it at the guy.
You can aim it to the little basket.
And really, it's got RFID in it where all you have to do is press a button and then you're registered with that state.
Yeah, that's right.
And so, but yeah, it vacuums its own quarters out of the seat.
That's the seats, yeah.
It's almost going to cause a die out of the buzz because there's nothing to buzz
Nothing
about.
to talk about anymore. Yeah, right.
Yeah,
They're just selling the cars.
When
People are buying them.
automotive reviewers have nothing negative to say, they also have no job.
Nothing to say. Yeah, that's right.
It's,
we can do a little consolidation over here on the blog.
Yeah, let's talk about Audi.
That's right.
I mean, it's going out so positive that
good deal.
And I'm pleased to see that.
Absolutely.
I've got a deposit down. Of course, I can get my money back if it goes the other way.
Right.
But
sounds like it's going to be great.
it sounds like it's going to be a fantastic car. It already is, and I can't imagine what would get in their way to ramping up the production.
Mm-hmm.
They've got an enormous plant, some of the best people in the country, putting that together. And so what could be the problem? Hey, but it's not the only new car in my life.
No. There was something that showed up.
We had a couple deliveries this week. Let's take a look at my little bit of sunshine here. big gods and little fishes. Blaine, what have you got there?
Oh, you mean this old thing?
So to speak.
Yeah, so to speak. I guess we have outdone ourselves this time, or what do you think? It's yellow anyway.
You know, I bought a lot of cars on eBay, and I usually have good success. I'd say I got taken on this one. You know what's funny?
What?
If you buy from individuals, they're usually pretty honest.
And
it's the dealers.
You
that
got this from a
always get me.
dealer. Yeah, I know.
Yeah,
I know.
Somehow, if you're in the business, then it's okay to steal. You know.
Yeah, they feel they're equaling out. Yeah.
But yeah, this thing's a leaker and barely runs. Fortunately, we don't need the engine.
No, the things that are giving us problems right now is the engine, and that I think will go away.
It's obviously been wrecked and rebuilt. Kind of
Looks
like
like
the
it.
wheels, and I've always been a sucker for yellow cars.
Yep.
I think it'll make a pretty good project. What do you know about the thing?
Well, this is what, a VW Type 181. I guess that it was originally the early counterpart was a German military vehicle, I guess, for World War II.
Well, the Kubelwagen was the predecessor,
Was the original
Type 82.
Yeah, the original, right.
Kubel means bucket.
The bucket car.
The bucket car.
The bucket car.
And they were quite popular.
Yeah.
These started, they started producing them in 1968. Interesting story. Italy, France, and Germany were going to build a Jeep together.
Oh, really?
Called the Europa Jeep. And they planned that for 25 years. Never did
Just
get a car
planned
out
pretty
of it.
hard, huh?
Yeah, they just couldn't get together on that. It was supposed to be a NATO thing.
Okay.
Meanwhile, to fill in, they asked Volkswagen to redo the Kubelwagen, and they started kind of a cross between the microbus platform and a Carmen Ghia.
Oh, really? Okay.
Carmen Ghia pan is wider than
A little
VW.
wider, right, a little bit wider.
And so they started out with that in 1968. They built 140,000 of these things.
Isn't that amazing?
About
Wow.
90,000 in Germany, and then another maybe 20 to 50,000 in Mexico. It's a little, counting them out of Mexico is a little bit of a
A
problem.
little bit difficult, that's right. Uno, dos, tres.
Yeah, well, then they got to start over again.
Yeah,
Who knows?
that's right, uno.
And so, but it's an interesting vehicle. They used it as a utility car in NATO, and everybody was buying them. And they introduced it in Mexico in 1972 as the Safari, and in the United Kingdom as the Trekker.
Okay.
Didn't sell well at all in the United Kingdom. In 1973, they introduced it in the United States. They wanted to call it the Safari, but GM had a Pontiac Safari.
Oh, that's right. They did have
so
a
they
Safari.
couldn't use
Their
the name.
wagon, yeah, that's right.
So they called it the Thing. It's interesting for us in that this thing, would you believe, that the doors and everything are so light and it's so spare.
Yeah, it really is. I mean, it's very Spartan.
This thing is
This thing.
2,006 pounds curb weight.
Okay.
Here was the problem. Two problems. They introduced it in 1973 at $3,150.
Okay.
That was $1,000 more than a Beetle.
Than a Beetle was, yeah, that's a lot.
It was as much as a sports car in 1973.
Yeah.
1973, I bought a brand new Ford Pinto for $2,185.
Yeah, probably so.
This was $3,150.
Yeah.
And a full grand higher than the VW Beetle.
Right, that's a lot. Yeah.
Which was very popular in 1973. Ralph Nader got down on it and wanted it kicked out of the country for not meeting safety standards. And as a lot of cars were, DOT was ruining with their bumpers.
Oh, I know,
and their
everything.
lights,
They were doing a lot in the 70s,
That's, you
yeah.
know, and MG, I guess 78 was the last year. Because most of the European manufacturers just couldn't stand the horror of seeing their cars with these huge bumpers and these great big lights.
Right.
VW didn't seem to mind.
No, they did some weird things. They put those shock absorbers on the later model cars, and yeah, big, gigantic tail lights and things.
They hung with it, but this one has a peculiar problem in a ruling by the DOT called the windshield intrusion rule.
Really?
And that the problem with that is this windshield's about 4 inches from your forehead.
So you don't have far to travel before you whack it, huh?
And the only way they could fix it would be to put a big dash in and make the driver sit in the back seat.
Like the Swallow.
Yeah,
like
we
the
did on
Swallow project, yeah.
And so
It can be done, but
it
it's a
was
lot of work.
for sale for 2 years here. 28,000 were brought in. A few were titled as 75s, but they were just remaining
They were
74s.
remaining 74s, okay.
And since they didn't change the body thing much, people didn't know.
Who could care? Yeah, who could care
So
less?
2
yeah.
years of sales. It's supposed to be a fun wagon, kind of in response to the Myers Manx.
Oh, the Myers Manx, yeah.
The bathtub,
The little buggy.
the beach
yeah.
buggy.
Yep, the
And
little
so
buggy.
this was supposed to be a beach car. I talked to, I can't remember his name. I bought a hardtop for a Speedster from him that I've never got to fit on the car.
Oh, yeah. That,
And
yeah.
he was talking about doing these for the islands.
Okay.
And then I bought this one, but we're not the first. In fact, this would be an easy conversion for us because we get to watch somebody else do it.
Oh, good. One of our viewers?
You recall last week I introduced you to Jeff Southern
Yes.
with the Allen Bradley Rockwell controllers
Yep.
and so forth.
Yep.
Well, since I don't know how to do it, he's going to give us a little video lesson and update us on his VW Thing project, which we're supplying a lot of the parts for.
We are, okay.
Let's see what Jeff's up to.
Take a look at Jeff's project.
Hi guys, it's Jeff Southern again. I thought I'd give you an update on my Volkswagen Thing project. I have the motor and transaxle out. I'm having the transaxle rebuilt with a 344 ring gear in it. I got my AC50 kit from EVTV. Pretty proud of this. Jack and Brian shipped it out to me really quick. You see the motor, the controller, the programmer, the wiring harness, the chill plate, and the plumbing for the chill plate. Probably the majority of my work I've spent on the car right now has been more or less related to cleaning things up. The engine compartment was very greasy, grimy, and rusty. So using some sandblasting equipment, I blasted this car for about an hour, hour and a half, and sprayed some. I just have sprayed some primer in here after I cleaned it up. Going to shoot some body color on it. There's a few places in the body that need to be touched up. So I'm going to get some paint matched and get this done. Kind of nice. I think I've got most of the greasy, grimy parts of this job under control. So I'm kind of hoping that'll be the last of it. But got the top off of it. The fiberglass top needed a little repair work done and some cleanup. So it's actually in my basement. I'm pretty good at fiberglass repair, so should be looking good shortly. Just wanted to give you a quick update on my project. Thanks. Jeff Southern again. I thought I'd show you some things that I'm working on here for the control system of the car. Jack showed you a very similar system to this one that I sent him that uses the Allen Bradley Micrologix 1100 PLC controller and a couple of I/O cards. This particular controller, if I can get this to focus in, has 10 DC inputs across the top, and it has 2 analog inputs. These analog inputs are only 0 to 10 volt, but they can be used for things like HVAC control, things of that nature. It does have a little built-in display where you can look at some information on the controller. You can check the I/O, you can do some monitor, you can check its Ethernet ports, for example. If you want to see what the IP address is set to, this is currently set to 192.168.1 and 10. So it is programmable, can be used to display diagnostic information, but primarily it's a little bit too small to be used in a car for anything other than diagnostics. On the bottom here we have some outputs. These are relay outputs and also have some high-speed DC outputs. This particular unit is powered by 24 volt DC. It's capable of running a PWM controller, has 2 channels at up to 20 kilohertz chopping frequency. So I'm hoping to be able to use this as a battery charger controller as well. A little bit weak on the analog circuitry design, so if anybody's got any tips or suggestions on how to go about that, I'd certainly appreciate it. Do have a few more components from EVTV. I've got the J1772 controller from David Kernzel, and I have one of his machined aluminum charging ports. This is an incredible piece of machinery. I do a lot of machining myself, so can definitely appreciate the work. This is one of the little brake transducers I got from EVTV. So if I get the batteries from EVTV, this kind of was going to be a little bit of an EVTV build. This is another device that I picked up. This is from CR Magnetics. What it is, it's a DC voltage transducer. It will convert 0 to 150 volts DC into 0 to 10 volt output. What this will do is let me monitor the pack voltage with one of the 0 to 10 volt inputs on the analog input card. I've currently got them wired to this one at the moment. The circuitry on it is pretty straightforward. I'll put it up here so you can see it. You basically have the pack voltage on this side, then you have your 24 volt DC on this side, your ground, and then your output return goes back to the 0 to 10 volt input. This is purely linear. This also provides, I believe it's 2,000 volts electrical isolation. It is DIN rail mountable. I know Jack hates DIN rails, but you can also mount it with the mounting screws. So this one will pretty much clip onto the DIN rail like that. These are also mountable on plates. They do have mounting holes for all these things, so you don't have to mount them on DIN rails. I did it just for convenience of setting up my test display. What I wanted to show you here is a little quick program. I've only had this for about a day, so I haven't had too much of a chance to program it. But what it does is it lets me program, like for example, I can reset the pack voltage by holding this down until it resets to 180 amp hours. You have to hold it down until the little arrow goes all the way across. It resets it. It gives me my pack voltage. What I have set up here is a couple of little circuits I made. This one just a 0 to 10 volt. Pretty good precision, but it lets me vary the pack voltage. As I turn it, you can see I can raise and lower the pack voltage. This one simulates a 0 to 50 millivolt output, which is very useful for shunts. So as you can see, as I turn it, I can raise the shunt up. I haven't quite finished my digital gauge yet, don't have the numbers on it yet, but it's currently scaled from 0 to 750 amps. If you notice in the video, the amps are actually reading negative and they're red. I can switch the leads on this, and because this is a bipolar input, it will actually read from minus 750 to plus 750 in this configuration. This particular input card does have the ability to read plus or minus 50 millivolts, also plus or minus 100 millivolts, so it'll work with just about any shunt. When I program these softwares, I do use a MacBook. Not real partial to PCs myself. I know Jack doesn't like them. So I think the next segment I'm going to do is I'm actually going to do a screen capture and show you how the actual programming software works for these two devices. So bear with me. Hello, Jeff Southern here. I thought I'd give you a quick overview of how this programming software works. I'm currently running on a 15-inch MacBook Pro. I use a product called VMware Fusion, which lets me run a Windows operating system on the MacBook. So basically I have a virtual Windows XP Service Pack 3 system running here. When you install Rockwell software, you basically are going to install two software packages in order to duplicate what I've done here. One of them is RS Links. This is the communication drivers for all of the Rockwell or Allen Bradley controller products. As you can see, I have an Ethernet driver defined, and if you drill down, you can see the MicroLogix 1100 that I was showing you earlier. And you can check out its device properties, do some things like that. So this is just the driver software for it. The actual programming software is a product called RS Logix Micro for our MicroLogix series processors. The Lite version is a free version which does work with the 1100, so it's a free download. Normally Rockwell charges a couple $100 for their software, but in this case it is free. Thought I'd show you a system. I'm currently online with the processors. You can see by the remote run and this little spinning icon. So for example, if I turn up the amp hours, you can actually see the pack amp hours go down, and you can see different things changing in there, like I'm running about 500 amps right now. Carry it down to roughly 0. So it's doing some things in there. Ladder logic is a programming language that was created to try to help. In the 70s, there weren't very many programmers outside of Silicon Valley, but they needed people to be able to program logic of machinery. So they came up with this idea of ladder logic, which looks like, for all practical purposes, a wiring diagram, so that the electricians would be somewhat used to the to reading electrical diagrams, they figured they could understand this ladder logic better. It works extremely well for machineries. It is a very low-level programming language. It's almost a way of making assembly language visual, is the best way I can describe it. All the memory is stored in files over here. For example, the output file, these are the physical outputs on the unit. So these are the hardwired outputs on the unit. We have an input file. These are the physical inputs on the unit. You can see them in binary, or I can see them listed in decimal. For example, if I want to look at the the current readings on the analog cards, as you can see, if I change this analog card, you'll see the reading here go up and down. All of the memory is stored in files. We have a status file, a binary file. This is simply bits. It's just binary bits to do what you want with. They're on-off memory locations. We have timer files, we have counter files, control registers, integer files, and the floating point file. I'll bring up the floating point file just so you can see it. Shrink it down a little bit. As you can see on 0 here, that is my amp hours. That is the raw amp hours that are left in the battery pack. If I come over here, you can see that this is the accumulated amp hours. This is a math result register. This is the current amp draw. This is what it actually seen across the scaled value on the shunt. So that is, as I turn it up, it'll go to 750 as its max, and I can turn it down, it will be roughly 0. A long time ago, I learned when you're totalizing very, very small values, when you're totalizing something per hour, your actual increment is in milliseconds. So you have very, very small numbers that you're dealing with, which you can see by these exponential numbers in the controller. So what I found is by creating a temporary registry and always adding to the temporary registry, and then when it reaches a certain predetermined value, I add it to the total. By doing that, you eliminate virtually all round-off errors in the processors. And I'll explain a little more about these registers. This one is an absolute amp draw, so basically when I turn it up, even though the real amp draw may be reading negative, this will display as a positive value. Do this basically for the display purposes. Show you a little bit about how the logic works. I'm going to do an online edit. I'm actually just going to enter a do-nothing code, more or less. It's just a latching circuit. I'm going to create a normally open contact, normally closed contact, and an output coil. So this is just like an electrical diagram. Normally closed contact, normally open contact, and an output coil. I'm going to put a branch around the normally open coil, and on that one I'm going to put another normally open contact. And I'm going to use the B3 memory file. As I said before, they're just a place to store binary bits. So I'm going to enter B3 colon word 5 slash bit 0. Actually, that is one I have used for something, so I better use something else. So let's just go to word 4. I'm sure not used for anything. Alright, and I am going to create a new one called B3 colon 4 slash 1 for my stop bit. I'm going to label that one stop. And I'm going to go ahead and enter a comment on this one as well. And we're going to call it start. And then we're going to create one over here, and we're going to use the next bit, B3 word 4, bit 2, and we're going to call that run, just like a latching circuit. Then I'm going to copy this over to here. So basically it'll latch itself in. It's a latching bit. Notice a little ease by here. It wants me to verify my wrong, so I'll select verify. It's good, so I'm going to tell it to test the inputs, and then I'm going to assemble them. So basically I'm going to toggle this bit in memory, and it does what you would think. When it closes, the electricity flows across here, and then when I toggle it off, the electricity is still flowing around the branch, so the output coil stays on. So B34 is on, and I can actually go over here in my binary file and look at that, and that is the coil. That is B34 right there, and notice it has the description run on it. If I want to stop the branch, I can toggle this bit, because that's a normally closed bit. it killed the circuit. So basically it came on and it ran the thing. And now this is a very, very simplistic version of what ladder logic can do. Here is another circuit that basically does something a little more interesting. This resets the current amp draw on the pack. This is actually what does it. I use this bit from the HMI so that when this comes on, it starts a timer. It'll time for 2 seconds. This is in milliseconds. And then when you get the done bit on the timer, I will move the value that's in F8:8, F8 word 8, into F8:0, which is my pack capacity. So in this case, it's going to move 180 into the pack capacity. And as you can see, I'm going to turn the shunt draw up. So this is simulating about 700 amps. So my amp hours are dropping relatively fast right in here. And I am actually going to press the button on the HMI. You won't be able to see this, but you'll just have to take my word for it that it's working. And it will reset the pack capacity. Now, something is wrong with my display. Oh, I currently have it in edit mode, so I can't do it right this minute. Just wanted to give you a quick overview of what ladder logic is. There is interrupt routines in here. That's what the totalizer routine basically does. Just so if you want to see how it's doing the amp hours, I basically do a scale with parameters. I enter the minimum input, maximum input, minimum engineering, maximum engineering, and I arrive at an output. I do the same thing with the pack voltage. I take the pack voltage raw input, 0 to minimum, and then the scaled 0 to maximum, which is 150 in this case, and I arrive at a pack voltage. Then I start doing some math. I multiply that value by this mathematical formula creates my amp hours in very, very small increments. So I put that, it ultimately gets put in my accumulated amp hours since the last update. When the update, when the value gets greater than a certain amount, I take that small temporary value and add it to my pack total, or subtract it if it's a negative number. And that's how I arrive at my pack. So these little bit of rungs here do all the amp hour calculations. They'll also do kilowatt calculations. I just haven't programmed them yet. Another rung that does something that you might be interested in is the daughter mode. Basically, I have a value you can set for the daughter mode in case I've got it set for 25 amp hours. So if the daughter mode, if the current pack value is less than 25, then I'm going to turn on an output, which we can send to the controller. Again, this could be this is a relay output, so this will force the controller into the daughter mode, which will limit the amp draws that it can take. So this is a very classic example of something that actually does something useful in the pack. I'm going to flip over to my Internet Explorer, which I have pointed to my display. These little panel view components actually program inside of a web browser, which is kind of unusual. They have a JavaScript built into them that lets you program them in there, and I've created a project called EVTV. I'm going to select Edit, and it will let me go into the project. And I'm going to point it back to the main screen here. And this is the screen that I created. It has a little gauge on it. It reads the amp draw. If I click the amp indicator and I go down here to my little connections, you'll see that I'm pointed to the amp draw connection tag. These HMIs program on the concept of tag. A tag is a piece of memory. Could be a bit, could be a real floating point, or it could be a 16-point integer. And as you can see here, that's exactly what I've defined. I've got absolute amp draw is F8:16, and if I call up my programming software, F8:16, and that is my absolute amp draw at the moment. And again, if I turn my pod up, you'll see it changing state. So I go back to my panel view editing screen. So you can see this is how I created the tags for the product. So each one of these, and this is a button I put on the screen to do the pack reset. This is a little bar that indicates you have to hold this button down for 2 seconds so that the pack will be reset. So that this gives you a progress indication to let you know that it's being reset. I have a simple trend screen. The trend basically lets me trend numeric values. In this case, I'm going to trend amp draw and pack voltage versus time. So I'll be able to actually see what my amp draw is over time and how the pack voltage sags relative to the amp draw. So this is a nice little thing built into the screen. On the configuration screen, I can set up the values for my shunt. Again, this is a bipolar input. It reads from minus 50 millivolts to plus 50 millivolts the way I currently have it configured. It can also read from minus 100 millivolts to plus 100 millivolts. So this corresponds to what does the shunt read. So when the shunt reads minus 50 millivolts, it'll be minus 750. When it reads positive 50 millivolts, it'll be 750. This will let me change the battery level at which the daughter mode will engage. It lets me overwrite it if I want to. And I can enter the pack capacity. If I don't want it to be 180 amp hours, I can change it to 170 or whatever is appropriate for my battery pack. So again, it gives me the ability to calibrate and change things inside the controller while I'm in the car. I don't have to have a computer hooked up to it to get at these variables. And since these are programmable, I can put whatever I want on here. There's plenty of graphics objects you can display. You can put multi-state buttons, numeric inputs, strings, bar graphs, analog gauges, linear gauges, and trends. You can put pictures, lines, graphics, and tools, little basic things you can draw with. It does have some alarming capability, so these little controls here allow you to do the alarming. It does have user security on it, so you can actually enter security for these screens. I'm probably not going to in this car, but you get the idea that you could, so you can prevent unauthorized access to, say, being able to change the parameters. You can use graphics and photos for these gauge dial bezels, which is probably what I'll do here. The built-in one's fairly limited. It just draws these tick marks. It doesn't do anything more useful than that. So this is how it works. This is how you build the screen. And to put it in the controller, you simply just tell it to run. And since I haven't verified it, it wants me to verify the application's running. And the application started up and is running currently in my little HMI display. So you program it with a web interface. So the only thing that's required is a Windows operating system, XP or above, and Internet Explorer version 8 or 9 will work. This is the programming software again. You can get this for free from the Rockwell website. If you really want it, you can contact me and I'll be happy to provide you a download link so you can get a copy and play with it. And just wanted to give you a quick and dirty about how this works and why you might want to use them. Thanks.
Oh my God, huh?
Oh my goodness.
Look at that old thing.
Yeah. I think I'm going to like playing with my thing.
my ding-a-ling. Ding-a-ding.
No, it's kind of a gig. I think there's room in the front for batteries. There's room behind the rear seat where you can almost just like set them in there, and the engine compartment should be big enough for anything we want to do.
I think so. Yeah.
And the things were surprisingly lightweight, a little over
that's what you were saying,
2,000
a couple
pounds.
thousand pounds. Yeah.
2,006 pounds is curb weight.
Okay.
And it's not going to be air conditioned or ever elegant, and you are kind of sitting scrunched up against the windshield.
Yeah.
We may need to follow Jeff Southern's lead and rearrange the seats a little bit.
The seats, yeah.
Move them back or something. I don't know. Make this a reclining thing. But anyway, his project is he's way out ahead of us.
Oh yeah.
And I think he's going to have a bang up display. Since he's given me the stuff and I don't know how to use it, maybe he'll just send me the software when he gets it all worked out.
Plug it in.
And we can go from there.
That would make it easier.
Actually, he already programmed mine. Really.
Oh, really? Okay.
Yeah, I've just never
Just
loaded
never
it
have
up.
a chance to
You
do it.
have to use Windows. I detest Windows. He's got a Mac, but he uses a VM to bring it up
to
in
do that in
Windows
Windows.
mode, and I'm just not going there. So, but a great looking build. I think he'll be here at AvCon with his thing.
Sounds like it, yeah.
My God, it's almost 1st July. It's not going to be a hard build, but we're kind of in the middle of the Escalade. I don't know if we'll have ours done or not, but we could have a thing drag race.
Yeah, there you go. Yeah, thing versus thing.
New batteries. We have got them in. We are going into the battery business, albeit somewhat reluctantly. It's very capital intensive. We spend a lot on batteries, and then we make a little bit on the flow of them through here, and they're heavy. This is exactly the kind of business I always told you I didn't want to be in. But I'm trying to get set up where you can get most of the stuff you need to make a car at EVTV. And what we're hearing from our viewers over and over is that there's a lot of fear and distrust out there because there's a lot of scams.
Yeah, there's just it's wide open out there, and you just don't know who you're dealing with.
It's Dodge City 1880. That's where we're at in the industry. We've been there before with the internet thing.
Yeah.
And God, was there a bunch of opportunists and
stuff
charlatans going on in that.
Yeah.
And they eventually did get weeded out, but it took quite a while. And you're in Dodge City 1880, not 1888, 1880. That's a crucial 8 years there.
That's right.
And I didn't realize how this had people bound up. So, now we're struggling to get the right thing in the box.
Right.
One guy ordered a.
What did he order?
He ordered
The proximity sensor.
Proximity sensor, and you sent him a brake transducer. They're both little metal dildo-looking things, but they're not the right
They don't do
thing.
the same thing. See, I'll just send stuff out and see if they'll send us back, a check, PayPal. I mean, they got it.
So we're having adventures in learning how to sell this stuff. We're going to sell the CA battery with the strap and the bolts and the washers and the block to sand them off. And you've got a little rope.
Yeah, we got a little rope thingy.
This is Brian's invention. I think it's kind of cool. You take the bolts and bolt that to the terminals, and the nylon rope is strangely non-conductive. And then you got a little handle for the battery to lower them into boxes or pull them out of boxes. And you'd be surprised how often we use that.
Yeah, and every now and then I just might slip a little piece of copper wire up through the middle of this thing and make one just to see if anybody's paying attention.
Just to see if they test you.
That's right. See if you're really using it.
So, we're getting into the battery. We got the batteries this week. I've photographed them. We've tested them. We've done charts. Let's take a look. It's kind of steamy back in the battery lab.
The battery lab, yeah.
Let's go watch me suffer. Okay, here I am back in our messy battery lab. It's we're coming up on July here in Missouri, and it's 105 degrees out today. And so I'm working under the light in our unair conditioned shop, trying to stay cool. The object of our attentions is our new shipment of CALB gray cells. They call it the CA series. This is a CA180A series cell, and we received 100 of them. They have a little different distribution. For one thing, they come marked with their amp hours on them, and about 67% of them were between 196 and 198 amp hours marked. This one did not test out that way in our test, but I did put it under a little bit of current, about 100 amps. And your standard charge and discharge rate for all the CALB batteries is 0.3 C, or in the case of a 180 amp hour cell, 54 amps. So we did about a 0.5 C in our test. The battery is much slicker. The first thing I noticed about it, taking it out of the case, is it has smooth sides instead of these ribs that we have on the side of the SE cells. I have two thoughts on that. One is the ribs are kind of nice in that they maintain channels for airflow in your battery box for cooling. However, my experience has been that they mostly serve to get interlocked with each other and make it heroically difficult to pry a single battery out of a pack. This is a little rope that we make. It's a nylon rope with 2 terminals on the end. I can bolt to the 2 terminals of a cell and use it as a handle to pull them out of a box. The rope's non-conductive, so I don't short out the 2 terminals. Handy thing to have. So this is a much slicker case. I think it looks a little more elegant. The top of the cell is our normal M8 tap, and really quite similar. They have some little pawls, apparently for their assembly, some sort of a wrench. Otherwise, they're identical to the SE cells terminals. Again, you have a vent cap in the center, which will blow off if it needs to vent. And we use exactly the same M8 16 millimeter bolt with a 1.25 millimeter thread, and that's your bolt. Of course, we use the Nordlac washers and our braided copper straps. The 70 millimeters that work with the SE work perfectly with this as well. And so no change in our strapping procedure. I found it interesting after we came up with this and videoed it, that now in their little book, CALB talks about taking some sandpaper and taking off the corrosion off the terminals before you connect them. And so we're having some sway here. They've also adopted our concept of undercharging slightly and of course avoiding over discharge. The advantages that they tout about the cell include a strongly increased power density, and we've proven these to about 8C or 1,000 amps. We've actually run vehicles at 1,000 amps for 15-20 seconds using the SE cells. Their figures would tend to imply about a 70% improvement over that, which is almost hard to believe. That would put this cell certainly, in the 1,800 or 2,000 amp class. We're going to call it 12C instead of these at 8C. The other area where they apparently got some dramatic improvements in performance was in cold weather performance. One of the things about lithium iron phosphate cells is you do not want to charge them below freezing. That's 0 degrees centigrade or 32 degrees Fahrenheit. They do not do well at all there. You can drive the car in cold weather, and at minus 4 degree Fahrenheit or minus 20 degrees C, they show a marked increase in the ability of this to put out its normal capacity, about 87% of normal capacity, as opposed to 77% on the SE cell. So cold weather performance, power. They also claim at different discharge rates, this would be more closer group to the same capacity. I'm not finding that particularly to be so. This cell was marked as a 198 amp hour cell. I got 190.5 amp hours out of it. This SE cell, it was not marked, and I got 195 amp hours out of this one. And we've done this kind of in parallel in our testing. The testing has been particularly gruesome. We've got some very smooth curves, but what we did was actually sit here and wrote down the voltage and the current into the cells every minute on the minute. And let me talk about my test setup a little bit. We've got a little JLD 404. We sell these. You're probably familiar with it. One feature that you may not be familiar with is it does an hour and minute. It's got a clock that it'll display. And so I could use that to detect the passage of the minutes. This JLD 404 I'm using with a 250 amp shunt to give me a fairly accurate current reading. and we both charged and discharged at as close to 100 amps as we could get. These two little things, we're going to start carrying them in the online store. This is a JLD, what do they call this? 5740. All this is a voltmeter, but it has a couple of interesting things. It has a 500 volt range, a 100 volt range, and a 10 volt range. Now our JLD 404 will measure voltage. However, the only range it's got is 500 and 100. This one has a 10 volt range, and as you can see here, I get a fairly precise 2.818. I have 3 digits to the right of the decimal point display on a cell. And so it makes a great single cell voltmeter. You can adjust the zero on this to calibrate it. And so I've got these kind of calibrated with my old Agilent 34405 to give me a very accurate voltage. Of course, like the JLD 404, it'll also drive a relay. So I have 2 contactors. This is my discharge meter, and when I hook it up, it will let me discharge and do anything I want to, right down to 2.5 volts, at which point it disconnects the contactor from the load, and I can't do any more of that. I've had too many incidents of me getting off in a conversation and taking a battery down too far. The other, I have another contactor that works off of this that connects it to the positive terminal of our power supplies. I've got a power supply here, a Lambda, that'll do, it'll only do about 10 or 11 volts, but it'll do 200 amps. And so I can use this to charge them fairly quickly. However, I've got it set up where when it reaches 3.65 volts that it disconnects. Our charge curve is what we did first. The batteries come about 55 or 60% charged. And whenever you're storing them or parking your car for a while, that is the proper level to maintain the best life of your cells. So they come to us about 55% charged. This one, we actually know that it puts out 190 amp hours, and so we started at about 104 out of the box, and we started at 3.30 volts, which is the same voltage we get all our cells at. We applied 100 amps. I'm going to put this up on the screen. This is a standard lithium-ion charge curve, and what you'll notice is the 100 amp charge across the top. You basically charge these cells. You don't have to charge it at 100 amp. In fact, the recommended charging is the standard charge current of 0.3 C or 54 amps. It would be unusual if you can afford a 54 amp charger on a pack of any size. So you'll often be charging at 15 or 20 amperes. In any event, the charge process is to maintain as much current as you can until the cells reach 3.6 volts. And at that point, you go out of the constant current mode and into the constant voltage mode. And you want to hold that value. Now, as the energy in the cell goes up, the voltage would normally rise. So to hold it at 3.60, your current has to go down. Most chargers do this automatically. In fact, this power supply tries to do it automatically, although it does it badly. And I have to sit there and kind of babysit it and nudge it along. It's trying to help, but you gradually turn down the current until you maintain this 3.6 volts. Now, when do you quit? We get a lot of questions about the LCON and the charge curves. The curve we like is technically called 502, and that's because it's amp hours divided by 30 on the termination, which on a 180 amp hour cell would be, 5 amps. That's actually too low. The specification is for 0.05 C, or 5% of your battery capacity, which would be 9 amperes in the case of these CALB 180s. And as you can see, what was alarming about this test is from about 3.45 or 3.5 volts, the voltage shot up, and it wasn't 2 minutes until we were done. And when we got to 3.60, me and the Lambda, both working at it, could barely keep this current coming down fast enough to hold it. It has a much sharper charge curve on the late end than the Sky Energy does. And so it's, the other thing is they're kind of admitting now that if you charge to 90%, our box of cells that we got varied from a low of, marked anyway, of 194 amp hours to a high of 201. And that's a 7 amp hour spread. If you will charge these cells to about 3.5 volts across the series, we could have that entire 7 amp hour spread above us and overcharging them and still not really go beyond the 3.6 volts. And so this concept that David Andrea and them are doing, that you have some at 3.5 and some at 5 volts, is nonsense. By undercharging slightly, you really are sure that none of them even get to the 3.6 book. And so that's what we like to do. This is so sharp that I would say if I was running these cells, we would normally charge them to the number of cells times 3.45 volts, because there's just nothing in here for us after it starts turning up this knee. The discharge curve is kind of a little different. I'll put this up on the screen again. We discharged at 0.5 C or 100 amp. Actually wrote down the voltage every minute for 120 minutes. This is a lot of fun to do. I did 2 of them in one day. I was pretty wrung out in the heat. We got 190.3 amp hours out of it before hitting 2.5 volts and our little voltmeter disconnecting us. And that's at 100 amps. In the chart here, you can see we've got ampere hours across the top and minutes plotted across the bottom. We're actually graphing the voltage measured from the beginning. We started out with a battery of 3.35 volts. As soon as we turned on the 100 amps, it jumped down to about 3.26. And then we had a long flat section down to, and they say about 3.1 volts is 90%. Now, if you compare this to the Sky Energy cell, 90% is more down around 3.05. I've seen it even 3 volts. And so we've moved part of we've made a sharper curve on the discharge. And so we have a steeper cliff we're going over the edge of, and we do it a little earlier at about 90%. So if these cells get down to about 3.1 volts piece, and you can calculate this for your pack on a 36 cell pack at 3.1 volts, that's 111.6 volts. There's nothing for you there after that. You've got 90% of it, and all you have after that is trouble. Now that's a static voltage, or in this case, a static discharge at 100 amps. But if you're below 112 or 111 volts sitting at a stoplight, you're done. That's about all you're going to have. And so it's a little sharper curve, but it held up very well up top and was very smooth and very reliable. But once we got below 3 volts, it went into a dive, and it wasn't 2 amp hours till we were at 2.5. So again, the CALB cells tested out very well. If anything, they're sharper on both the charging end and the discharging end, and they prove kind of emphatically that there's nothing in there for you in overcharging these cells really above about 3.45 volts per cell, or in discharging them really anything below 3.1 volts in the case of the CALB CA series. You can take the SEs down to 3 volts, but you don't really get that much between the 3.1 and the 3. And so what I'm seeing is an improved cell, nicer case, a little better quality materially, and clearly they've made some adjustments in the chemistry. And so they're not exactly the same thing, but you can tell it's the same family of cells, and it behaves really quite similarly in a lot of respects with the SE. Next week, or one of these weeks, we're going to cold soak them in the freezer, put them in a cooler, and measure them for cold weather operations, see if we can tickle any differences out between the two of them. But for now, that's a preliminary look at our first shipment. We got 100 of these 180 amp hour cells in this past week, and we've already sold quite a few of those, and we'll be getting more in as we get into July. We're going to sell them with, they'll come with the straps, the Nord locks, and I'm going to try to throw in one of these little rope hangers and a special Lowe's sanding block to knock off the corrosion off both the straps and the terminals, and we'll have them in the online store available immediately. That's our first look. We're going to do some other tests for cold weather work and some other things in the weeks to come. Stay with us.
Now, you see, look at what we do for you guys out there in EVTV land. I mean, our nerds are we give it up for our
120
guys.
minutes of sitting there writing down voltage every minute on the minute. Yeah. It's but it makes very smooth and pretty graph.
It does. Yeah, the graph is smooth with the data points every minute.
There's very little. You can hardly throw a cat between the two batteries and get it to land on anything, though, from those graphs. We're going to have to test further to find any differences. One of the big ones they claim is cold weather performance.
Yeah, that's
I think I can simulate that, but boy, the tough one, and the one everyone's going to want to know about, is can it put out mustard?
Is the higher C?
Yeah, see, if they can do 12C, then your 100 amp hour cells could be
doing 1200 amp.
Yeah. And so, but other than putting them in a car and stomping on it, I don't know how.
I don't know what else to do. Yeah, to get under that.
And
kind
even
of
then, you get 10 or 12 seconds of it until you hit a wall or something, and baby. And so I'm not too sure how we're going to work that test.
Okay.
Maybe I'll get a 40 or something, which they really are a little different in the different sizes is a problem with that.
Oh, yeah, that's true. Yeah, if you test it
But
different.
if I got like a 40 and tested it at that'd be 480 amps. God damn, I've blown up a lot of stuff back
We
there.
do. I know,
Anytime
at
I
that
go
level.
above 400 amps, things start smoking and arcing and throwing little tongues of fire at me. And,
send them out, get them fixed.
man, blowing up test equipment.
That's right. One time we had no loads.
Yeah, I was
we had
out
no
of
power
loads.
supplies.
I'd burn up all my loads and power supply kind of all in 1 week.
It was
a terrible
a
week.
couple of days.
I don't want to go back to that.
No.
The Mark
Weisheimer fixed it.
it took him weeks to bail me out of that.
That's
He's
right.
like,
Put
we got a UPS truck going back and forth to Mark's, and he's working full time on my test equipment.
That's right. Trying to get us back operational.
Get it back and get us up. But that's the batteries.
Nice.
And so that's pretty much the show this week. I've got some videos from Ani Kloppenberg.
Oh, yeah, that's what you were saying. It's,
I could,
one of our
I
viewers
could
sent something
tie in a little more electric boating if you wanted to see some of that.
in. You know, it might make people think cooler.
Let's take a look at some water sports in July.
All right.
As a very first thing, I would like to share with you all the unboxing of our first motor and the dream to build something electric. The dream starts up here, but it's nice to see something for real. And in this case, our very first part to make things real is going to be a Kostov 11-inch 250 volt version motor made by Balkan Car in Bulgaria. And it's just come in. That would not be the way to do this. Okay, that's almost easy. Needed. And the first thing I'm going to say, it's smaller than I thought it would be. You know, I know what it's supposed to do, so it's a good thing. But coming off of the truck and here in the workplace, that's good. I mean, there she is. But I guess they must think, hey, it's an electric motor. What do you want to book? You want us to hold your hand? So, you know, they don't. But we're real happy. So it seems my Bulgarian friends could not find the V-Markt. Hello? You have the batteries? That's the batteries? Very good. Well, we're going to try and put them in my little car. And at least, finally, I will have my lithiums. Yay! Well, we got the batteries. Don't ask me how they fit in there, but they do. Transport wasn't quite door to door. It was more door to 10 miles down the road. Truck couldn't get here, but there they are. And I managed to get them out. So let's open them up. Pretty much we are getting 3.3 across the board. .3, 3.3, 3.3, 3.3. Now we could kind of do this all day, and I just have been trying, but not that much drift, right? Real-time Wi-Fi logging. At this time, we're currently at 25 amps and 11 volts. So that's safe to touch, folks. So we're not here to kill anybody. We're actually here to show them that the future is fun. It's new electric, and we're having a great time. Thanks a lot. So here we are with the 1974 Glastron. It's pretty much a labor of love. We've had it now for about a year and a half or so, at which time we also entered in the Build Your Dream EV competition for EVTV. We were lucky enough to be one of your finalists, Came over to see you, what was it, June of last year. Then came again for the EVCon. Didn't win your prize. Went to Brandon Hollinger, who's doing the electric cab over in Pennsylvania. So we'll be interested to follow his build. We've come through the winter with a few extra EV parts. We got most of the system together, actually practically all of it by now, and we are hoping to start testing the boat in the water in about a month or so. We have everything set up on the test bench behind us, so I'll take you guys over there and show you what we got. Well, here's our test bench setup in true to form. We kind of got this idea from you when we visited last June. We saw the double motors for the Escalade up on the bench. We figured that once all the parts are in the boat, if something does work or doesn't work, we're never going to know really what is what, because we hardly know these parts. We're seeing everything for the first time. So we figured we'd put it out on here, get it to work. For us it feels kind of like the 1980s Knight Rider episode where Kit is all laid out. She's alive, but she's not in the car. So anyways, we've got our Winston batteries. We have 95 90 amp hour batteries. We're running at, say, 313 to 320 volts nominal, depending on where we are with our stator charge. And I'll set up and do a little demo. Well, this is the end of the motor setup on the table for now, because for the first time, the motor is going to meet the boat.
He likes to be famous. Raymond.
Ik denk dat we er nu wel zijn.
Ik ga een foto van Ray maken. Ik zal een masker uitknippen met ogen, die doe ik op. Het zijn allemaal Raymond.
Dat blijft gewoon.
Here is our little testing station. So we have the PowerLab 8, and we have a 5 series pack of Winston 90 amp hour batteries. And then I have 4 12 volt batteries from an electric motorcycle, electric scooter really. They're all in parallel, 50 amp hours each, and so that's 200 amp hours. And then here is an old PC that is running the CSS software that comes with the PowerLab 8. Now you'll see that it recognizes the 5 cells and their respective voltages, and it's giving me a overview. I set it to a 30 amp discharge current, so that's 1/3 of the amp hour rating. And it's showing me a increasing number of milliamps that I have taken out of this pack. At this moment we're at 11,000 milliamps, so 11 amp hours have gone out, all of these are. This is a setting I made ourselves, so it has the A123 standard settings, and I put it at LifePo 4 90 amp hour high discharge. What I'm telling it to do, here we'll see the supply tab. So I'm running at 13.4 volts on the regenerative discharge. I'm putting in 40 amps to the battery, well 38 something. It's running at about half a kilowatt. The settings I had to put in to do this are over here. So I told it that we have a battery power source. It's a flooded deep cycle battery, and I'm allowing it to max regen about 42 amps. I need the higher setting than standard, because at 13.4 volts, if I want to take 30 amps out of a 16 volt pack, I need some more amps. But so far it seems to be running fine. On the preset tab, I'm running a pattern. I've told it to discharge unbalanced to 2.9 volts. So it's taking its max discharge rating and it's going down until one of the cells is going to hit 2.9 volts. So on the discharge side, it's regenerative. I'm doing constant current, 30 amps, down to 2.9 volt. And on the balance tab, I have no balancing. This is because I figured out that if you turn on balancing and you want it to balance to 2.8, it's going to start balancing at whatever state of charge you start at. So it's going to start using a bypass and using the balancing leads. I'll show you those over here. So here we have the PL8 set up with its two main leads going to pack. Whoops, the camera crapped out on me there. I was saying this is our pack positive on the 5 series pack of Winston 90 amp hour cells, and pack negative, so they're connected to the main jumpers. Then we have the 9-wire pigtail that they use for cell balancing, and they have these little itty bitty wires that connects up to the individual terminals along the way, essentially giving you a battery management system that's able to shunt small loads as the voltage progresses. So what I was saying is that if you immediately turn on cell balancing, it's going to bypass the charge coming from the main leads, and the whole process is going to be a lot slower because it wants to continually keep the pack in balance on the way down. I'd rather have it max discharge down to a certain setting, in this case 2.9 volts, constant current, and then it does constant voltage until 4.5 amps, I believe, so it's already, we're going to see how that acts. Actually, I haven't had it down to 2.9 volts, so I don't know if it's going to do an immediate shutdown as soon as cell 1 hits 2.9, or is it going to hit 2.9 and then start a constant voltage mode until it hits 4.5 amps, which I set and told it to do. Kind of interested about that one. All the while, it is putting power into this lead acid pack that I have here. And even though it's 200 amp hours, it was kind of full when I took it out of the scooter. So I had the problem that immediately after starting discharge, the power lab would cut back the power because it only used its internal discharge, the lead acid pack being full. So the problem I had was, where do I put the power that I'm taking out of the lithium pack to bottom balance? I can't stick it all here into the lead acid pack. It's going to be full too quickly and limit the current that I can take out of the lithium, because the power lab is so damn smart and it doesn't want to blow up these batteries. So I figured, hey, why not use this free energy that Mr. Winston Chung has sent us from China and use it to break in our motor. So we have jumper cables set up, and here is our little jumper cable connection coming up towards our speedboat, ready to make the plunge, but not quite yet. And a good excuse to show you the interior. So here is, get set up. Here's our Kostov motor. It's an 11-inch motor, 250 volt, 260 amp continuous rating, up to 5,500 RPM. It's spinning up nicely on about 13.5 volts now. It's mounted with a 4.5 centimeter aluminum adapter plate, which goes straight to an original Volvo Penta bell housing. Volvo Penta is kind of like Merc Cruiser. It's a standard for stern drives, speedboats, and a whole lot of other kind of boats. This bell housing is still off the shelf, so in future we'll be able to put a kit into any boat that runs a Volvo Penta stern drive, and we know it'll fit, and it'll fit the original motor mounts as well. Raymond made us up a set that will clamp like the original ring around that motor on the COM section, and we'll still have the original rubber motor mount setting. Now it's had quite a few hours with the basic 12 volt that we, put a charger in connection with that. So possibly you can see it's a nice, the dark brown chocolate color that Tom Brunca was talking of Hellwig brushes. I think we're kind of getting there. The brushes seem to be seated nicely. Now for fun, we can kind of see in this system of regenerative discharge and running into the motor what our amp ratings are on the different parts of the system. For me, that was kind of like an interesting part of this experiment, even though it's turning out nicely now. So my software is saying I'm pulling 30 amp hours, or 30 amps rather, out of the pack. So let's see, we have a little DC clamp. Put it on to 0, and here we go. So we got 30 something coming out of the pack, minus 30, so that's good. Two things saying the same thing, I like it. We have, let's see, about 17.5 amps going through the jumper cables into the motor. So at, what is it? We can check the supply side, supply tab. So at 13.6 watts, or 13.6 volts rather, at 17.5 amps, that's what it's taken to spin this motor, unloaded but mounted to the adapter plate and bell housing. Within the parallel battery, how's that doing? We have about 5.96 amps. So this would be the net result of the 30 amps that I'm putting in, the 17 something amps I'm taking out, and this is what it'll show in the back of the pack where I'm parallel connected. Now this number is telling me I'm fine because the individual batteries not parallel connected were rated at something like, I think they could do about 500-600 amps discharge for pulse, and they could do about 15 amps continuous for charge. Since I have them in parallel, I figured we'd be okay, but now that we have the whole setup where they're also running the motor, I think we're well within operational parameters. Not that I really know anything about batteries, but you want to be safe or fake it along the way. What else do we have? So this is the high voltage board we had on the table. Everybody will recognize this light object shunt. It's a 1000 amp shunt, and we're not really going to do more than 550 on the battery side. So I think we're going to get, well, I'm looking at a 750 if they have it, otherwise we'll do the 500 probably. Here's our positive side. We've got the last contactor. We have 2 fuses on either side. They're a nice mounting point anyways. And then we have our fuses for DC converter and charger. Nothing's connected right now, so we're all finger safe here. This is what remains of our low voltage board. Right now everything's a mess because it's going into the boat. This is the DC-DC converter, a Meanwell 650 watt rated 50 amp DC converter with a very wide input range, but it might be crap because it's so cheap, so it's probably going to break. This is our Soliton one. Very happy with that. Has a lot of cool settings, as Jack has told you. Hey, so this is about it that we have going on right now. In about a week, we hope to make our first splash. So I'll update you as we build. Hey, you all still there? It turns out that my lead acid is just losing the war. There's just too much power in these batteries that Mr. Winston shipped us from China. And now the discharge has been reduced due to a volt limit. So we're above 14.6 volts. Maybe I should have set it higher. But I'm not sure. You know, I mean, I don't want to screw up the batteries in my setup. So it's limiting us to 26.8 amps or something on the discharge. That means that if I go to my cell tab and I'm still at 3.19 volt, it's gonna take a while before I have these 5 cells down to 2.9. Then I need to balance them. Then I've got another 18 sets of 5 to go because we have 95 of these batteries. We're at about, what is it now? 38,509. So we're at 38 amp hours that have gone out of these cells. I think that we're a little over half because I charged them a bit before we broke down the pack. So say I have probably about 50 amp hours in each one of these cells, maybe 60, who knows. So I need more power to come out of this pack, this lead acid pack that I'm charging into. Luckily, I have a bit of a converter going. So let's see if I can shed some light on this situation. Let's go back to the supply tab and check out that voltage number. Whoa! I think we're back to normal voltage, no limiting. That's pretty cool. I can hear the motor in the background losing RPM. And we're back to 0.5 kilowatt of regen. And I can see we're doing 30 amps of discharge current again. So how'd we do that? We had to add another set of jumper wires to this pack. This time it's connected to a 12 volt AC converter. That'll give us 250 volt, or 240, something around there. 600 watt max. And don't hurt yourself. Bit of a light. So, you got to keep on your toes to keep these batteries discharging. So much power in these lithiums, don't know really where to put it.
So there's
nice.
some boating.
Yeah, there's some boating. Electric boats are pretty cool.
No, we're going to have trains, planes, and automobiles.
Yep.
It's kind of like a bad John Candy movie.
Yeah, like a John Candy buddy movie, huh?
Yeah, right. We're going to have everything. Maybe I'll do an electric helicopter. But no, it's going pretty good. We need a BMS. If anybody's got an idea for a BMS, we actually were playing around with the Escalade and running that motor so much we ran the battery down and killed one of the cells.
We did. One of the cells
that had been bottom balanced. We still lost it.
Yeah, it went bad. Yeah.
And that actually, I had that cell marked.
Yeah, that cell was marked. We were suspicious of that cell from the beginning.
Yeah.
That cell 38.
Yeah. That it had never acted right.
No.
From when we put it in the truck. And sure enough, when this happened, I said, Brian, check that cell 38. But the cell opened up while we're charging it back up. Not really while we're down. I mean, it was coming up, but then it opened and took out my Manzanita.
Yeah, took out the Manzanita, yeah.
The Manzanita micro chargers, we've sent like 3 of them in for repair. Basically on the same thing. You cannot run this charger with no load.
With no load, yeah.
And you don't always have control over whether it has a load or not.
Especially when something like that happens.
And so I think they need to put some engineering effort into fixing that thing where it doesn't blow
Doesn't
something.
blow
It's a
itself up,
fuse
yeah.
or something in there, but they you send it back so they can change it every time this happens.
Yeah, and we, like I said, we've had it
So
happen
we
a couple
replaced the
times,
cell and charged it all back up, and we're back ready to go back into testing on the Escalade. I can tell you that we did not have a complete success. We turned up the motor fine in park or neutral, and as soon as we put it in drive, it idled out into the parking lot fine, and then when you'd apply power, it would slam that throttle plate to idle again.
Yeah, yeah.
I'm still confused about manifold pressure, Marie. We've got this tied to RPM. Isn't it really a function of load? How much load you're putting on the motor, how much power it's developing, or is it RPM?
I mean, I would assume that in the algorithm for the ECU, that's how it's measuring load. I would think it's looking at throttle at pedal position, that it's looking at RPM, it's looking at airflow. You know, I was probably looking at a few different things.
Yeah,
I think I'm
gonna try another circuit.
yeah. See if we can do another circuit. Maybe the opposite.
Go back and work off the same thing that we use with the mass airflow power, and the problem is it has to have a minimum voltage there. So I might take that 12 volt square wave PWM and do something different, like chop it with the Zener at a higher level, 7.5 volts, so we get more
7.5
at
volts,
low
yeah.
end, and then hope I don't blow it up
Blow
at the high
it
end.
up at the high end. Yeah.
Well, but see, once you're going down this comes up when you step on the
When
accelerator.
you step on the accelerator right away.
But once it's going, you're not going full power.
No.
I think that's what the issue is.
I think when it goes under a load at first, then it goes back to, it defaults back to idle.
The second strategy, and the more immediate one, is we have a expensive device. It's kind of like Jeff Sutherland's thing. I have to put it on a Windows computer, and I hate that.
Yeah.
But it's called HP Tuners, and that'll let us take a look at the diagnostic trouble codes
Yeah, all those
themselves.
DTC
And
codes.
the problem is we're going to have so many of them. Which ones are important and which ones are not is not necessarily something I'm intimate with.
Right. I think we can probably get a little bit of help and see which ones, because yeah, we need to find the ones that are causing that default idle condition. And I don't know how many there are, but yeah, we'll set the. We've got volumes and volumes of books with those codes. Jeez. Yeah, you know what I mean. What else were we doing?
Well, we'll see.
Yeah.
That's about a show for this week. Stay with us.
See you then.